would like to start with my presentation so that we can go ahead, basically. So view and then present. Okay. This will be some sort of an interactive presentation. It's not going to go over the slides only. So basically the idea of this webinar is bringing the robotics coding to teaching and learning in 2021. And we're going to explain what is riders, why riders, what does riders offer in general, and some references. And we would like to also explain the details of our Riders Ambassador program. For now, we are doing some good partnerships with institutions and organizations like funtent.org. You can have a look at that. It is an autonomous driving competition platform. We have hosted the 2020 virtual competitions of Maker Faire. Because of COVID-19, there were no other possibilities. So we have hosted the competitions of Maker Faire in this year. We are partnering with Google for Education. And finally, one of the largest robotics organizations for high schools, WRO, we are right now doing a partnership for bringing robotics to all around the world, especially in these times. So the idea of riders is coming from accessibility. So for right now, actually, the possibility of having a lab, a special robotics lab, is almost impossible due to COVID-19. And even there is a possibility to go and do the lab. Still, students have to do something at home, and they have to spend more hours on systems. And and to create such systems also on the hardware is not always practical and also possible. So I would like to explain this further, but once I explain all of this, we would like to share with you all the data that we have prepared. And if you can join to our ambassador program, we can open up a lot of more opportunities for you, for us, and for your university or school. So the story behind, so ACROM, the name of ACROM is coming actually from Accessible Robotics and Mechatronics. So our mission is to make robotics education and robotics research more accessible. And we are a worldwide provider of hands-on experiments with hardware and software and integrated courseware. But we have also right now developed a platform, cloud-based robotics development and competition platform, which we call riders.ai. So from the hardware environment and hardware ecosystem, we have opened up a new space on the cloud and on the online space. And we have developed riders to make robotics more accessible for everyone. So that's why I would like to explain the details of the riders platform now. So the idea behind was, even we provide hardware platforms, it is sometimes for universities or for schools not that possible to buy the platform or to maintain it or to deliver it, to provide it to all students. It is sometimes very, very difficult. And also the paradigm in education is shifting into more project-based learning. So, for example, you can do exercises on lab experiments. These are very useful, but students have to also build some projects and should try their engineering in the long run. So that's why project-based learning was also important. And for right now, the spectrum of STEM education is covering now more advanced studies like artificial intelligence, machine learning, autonomous driving, and other concepts. So for this reason, we have decided to develop a platform so that everybody can benefit from all of these aspects. So what is Riders in general? Riders is a community-based platform where you can have a community where you can create robots environments, you can create courses, you can create assessments and competitions. And I'm going to go all over it with some of hands-on visualization. So for example, let me go and show to you some process. So Riders is a platform. You can directly right now sign up to Riders and see everything that I am showing, especially in the challenges and courses, for example. So in Riders, as you can see, I have here under section my courses, I have my projects. I can create groups. And once I create groups, I can invite some people to work together on several projects. And I have also challenges here under my challenges. And as you can see, and there's also dashboard. For example, on my, there is right now an ongoing competition and a line follower competition, as you can see. And many people have joined to our competition. And this is going to end of the year, and there's a robotics league behind it. So all these challenges, courses, etc., are based on online robotics IDE, which we call RIDE. For example, once I click, for example, here a project. This is the challenge. Yeah, for example, once I click a project will open, and in this project you can you have the documentation, you have the assignments for the students, you have the coding environment, and you have the simulator and other types of visualization. All are possible. Right now, what you are seeing is the RIDE editor. So in RIDE editor, we are combining all the parts for a robotics environment. One is the scene simulator, the second is the robot, and the third is the user code. As you can see, for example, here, once you click on the left-hand side, user code, and your code starts here, and you can start to code here, for example. And once you click the start, environment will open, and then you can basically start coding. And everything is set up for you in that sense. There is a documentation. As a teacher, you can also create and edit everything here that is shown. So for example, right now, you are seeing a robot, which is right now the platform is getting built. We need to wait for a second, but this case is about image processing with LineRider. This is meant to be used for high schools and universities both. For universities, we are also providing different levels of systems. In the concept of line follower, I'm going to explain in a short, but let us continue to talk a little about it. So as you can see, the robot has a camera in front, as you can see, and what we can do is we can access that camera right away from the sensors. And you are seeing the sensor of the camera, and you're seeing the white line here, basically. And if we go into documentation, we are getting some basics about the arrays and etc. And there are some robot commands. For example, let's use one of them, and this was the user code. As you remember, your code starts here. What I'm going to do is I'm going to directly take one of them here robot move. Okay, so this is going to be, I would like to show how fast you can, for example, let's move with 1.0. And I'm going to, this is in Python, by the way. You can code on riders both in Python and C++. The reason behind is riders is based on ROS system, robot operating system, which is programmable over Python and C++. So I'm going to use some small coding here. While robot is okay. Move robot with 1.0. What I'm going to do is I'm going to click to the reset button, and everything will be started from the beginning. And as you are seeing right now, the robot is moving with a certain speed. I don't know how it looks from Zoom due to frame rate and everything, but the robot is moving and going to hit the wall because there is a physics engine already built in. And with that physics engine, you can also realize some realistic simulations as well. So let's change the code once again. And I'm going to use another function. And as you're seeing now, the robot is rotating around itself. So it is that basic. And with that, would like to show also how the camera looks like. As you're seeing, it is seeing the line and then there's nothing again, and seeing the line and then there's nothing again. So basically it's a live system. And with that structure, we are creating competitions based on these algorithms and everything. And as you can see also on the bottom, we are measuring some specs like time and robot status, and the status is in run, so it is not finished right now. If I jump to documentation, you will see also some checkpoints. So for example, this was the code that has been given to me. While robot is okay, robot move 1-0. And then it asked me to rotate the access to the camera, open up the camera as I did. And now it's asking me to print the image data as it is explained here, for example. So what I'm going to do is to use that. And I'm going to click the reset button. And what you're going to see is actual data of the camera. So what I'm going to do is click the watch not blocks now. So as below, you can see the camera data, and we can actually, the robot is not moving right now. And these all 60s are the gray ones, and the white ones are 255. So it is a grayscale range for the camera, basically. And with that, you can create an algorithm so that you can, using, for example, a PID and etc., by finding the line, so that you can create robotics algorithms and it can move flawlessly. I'm going to show a case, but in a different one. So I'm going to stop this. I would like to show you how to join. For example, this was the line follower challenge. I want you to get into this challenge competition. It is that simple. Actually, once you sign up, you click the join challenge, and then just clicking I agree and accept, you will just enter to this area. And once you open the competition project, it will be opened in a second. Just click the edit button, and then you will be on the project. So there is also a sample code so that you can run it and have a score. But I just would like to explain the details of it so that you can have a look at that. So this is the line follower race. And once you click the node, this is the code about getting the image and then finding the line over the small, very simple image processing, and then following the line over again and over a simple command but it is very simple. And once I click the start, it will follow the line very easily. But to be the best one, you require a lot of more complex algorithms in terms of PIDs and others. The best ones are in a very, very good position. I can tell you that. So please go to this competition and have a look at that. This is going to start now. And would like to show another point that it is now installing the space, but as you are seeing, this is my robot right now, and this is the sensor camera. Is the same concept, and I would like to also ask to you to encourage your students so that they can enter to this competition and use their skill set. And as you're seeing, this is a camera, and we are finding the line in this code with this is an array of pixels, and we are processing this array and finding the line and applying a P controller, a very simple algorithm for control, and then it is as you're seeing moving around, following the line. And once then the time is ticking, and it is calculating how much you deviate from the line. For example, in some cases, you are not moving perfectly, as you can see on the line, and we are calculating everything. And you're going to see, once I finish the line, I will get a score, and this will be listed here under Leaderboard. And right now, I am not on the list because I joined for the first time. And what you're going to see is in about in a second. Oops, that's not this one. Yeah, in a second I will get a result, and then we will see our score. So this is such an interactive platform in that sense, and you don't need to have installed anything. All you need to do is have an internet connection and a browser and a computer. And you don't need to have a great CPU power or something, because everything is calculated on the cloud. We are not using your processor and everything. So basically, this is also one of the important features of Riders. Everything is running on the cloud. Even this IDE that you're seeing is running on the cloud. So as you're seeing, I have finished and I get a score of 0.23. So let's have a look to the leaderboard. I'm going to refresh that. And as you're seeing now, I have, my name is Demo Rider, by the way. You can see it here, Demo Rider. And as you're seeing, I am the 18th place, like some of them, but there are really very, very good scores, as you also can see. And some of people are really trying to be the best. So I would like you to encourage your students to get into these competitions so that they can also practice what they have learned so far. That will be a great experience for them. So let's continue with our presentation. So as I mentioned, in this case, no hardware is required so that everybody can reach out. We can reach out to everybody. You can measure the student progress. So this is an important point. Let me show it in an example. So for example, here, and if I go to my Riders courses, there is 4 teachers. There's a manage button. If you click that manage button, you can add lectures here, add new lecture, and you can delete the lectures you want. And then you can click to inspect. And once you click the inspect button, the lectures and the details of the students or people will be shown here. For example, let's have a look to that student. Toprak Üstün has spent 3 hours, 19 minutes on that course. And I can see some details regarding which date and when he spent those times, and and also how many achievements he completed. Like, for example, he checked the front-end sensor heats and call move forward. So he moved the robot once, but he didn't turn left, for example, couldn't finalize it, but able to finalize the turning right on the wall system, and couldn't solve the efficiency problem. So you can see the achievement details, and you can see the details of the students, and you can assign such such assignments to students over this dashboard by opening up a new lecture, opening up a new course, or a project. Or if you want to examine on yourself, you can also access to all students' projects. So this is also possible. And want to explain a little more detail about in our environments, Python, ROS, and Gazebo simulation environment are built in. And what you can do, and also OpenCV, image processing, and everything are also built in. What you can also do is you can install additional packages. This environment is configurable. Like, for example, you can install additional Python module, SciPy, or you can install additional module like TensorFlow, so that you can do some machine learning or artificial intelligence applications. These are all possible. Another point that I would like to show is the scope of the simulations are very widely ranged. For example, you can create a drone environment where you can place some cameras on the drone, and you can command and develop algorithms on top of it. And what you can also do is you can work on a 6-axis robot arm, and these are developed by not ourselves, by KUKA itself. So and you can run industry level simulations here on the platform. I will try to give some more details about it once everything is set up. Let me open in another editor so that I'm more used to it. We have different editor options. This is also another feature where we can provide you also several different types of features with those editors. And I'm going to show another environment. In the meanwhile, I'm going to continue. So let me explain the infrastructure. So Riders is a cloud-based robotics IDE. You can access directly over your browser. And it's based on robot operating system, ROS. And we are using a simulator, Gazebo, which is right now industry level, an industry level simulation platform. And you can program, you can code the robots and the sensors and everything over Python or C++. And as I explained, there are courses in Riders with documentations and checkpoints. There are projects that you can work on, and you can create work groups. You can invite people and work together. You can create competitions on line follower basis, autonomous driving, and drone racing, and any other type of concept. And this is a very important question on some cases. For example, we are now providing a course for high schoolers, which starts from the very beginning, Python programming, like, for example, learning about loops, learning about conditionals and everything, and finalize in feedback-based programming, for example. And you can also, most of the universities are also calling high school students for to have a look at the university, and at some cases they're doing some activities. If you're a university teacher, I would like to ask you to consider this as a student magnet, I would say, for high schoolers. But if you're a high school teacher, especially in robotics, this is a direct fit for you. We have developed with the help of some robotics teachers from different high schools, and we are starting from very basics up to the advanced points. So if you are a high school student, high school teacher, I would like to ask you to examine it. And we can share with you the course so that you can really get hands-on experience. So there are a couple of lessons in this, starting with the, as I stated, with the programming, like loops, conditions, etc., and finalize in feedback and processing and everything. And I mentioned this as well in the courses. You have the possibility to, let me present. You have the possibility to check what students have done, how many hours they have spent, and we are also providing you some security. If the user has access over different IPs, you can check if the student is really doing it right or letting done by someone else. And we are keeping all the history of the student as well, so that you can check for any type of plagiarism or copying and directly pasting and everything. So basically, this is a space where you have the full control of the course. And this editor is built to simplify everything. Like, for example, you get easily this sensor image data. You can easily edit the algorithm, and by clicking the reset, you can try something else. You can automate this reset so that you can try some reinforcement learning and other aspects. And you can configure over the project configuration, where you can say, I want to have SciPy installed, I want to have TensorFlow installed, I would like to have these packages installed, etc. And I would like to use this robot, for example. And these are some pictures, like, for example, we can provide you a drone, we can provide you an electric car simulation, we can provide you a Toyota HSR simulation, and turtle bots, and then swarm robotics is also possible. All are possible. For example, here I have opened this project. So this one is, for example, Parrot Hour drone. So this is a ROS-based project. As I explained, for high schools, we just bridge the gap between the ROS and the simulation, so that you don't need to put any terminal type of code or everything, but there's this flexibility here. So I'm going to open up run a very simple code. I'm going to show there's this user code here. This will move the robot, going to take off. This is the Parrot Hour drone library. So you can give some commands, but I would like to show you some aspects. So you're going to see is the robot will take off, and now I'm going to open the front camera. And as you're seeing, I am looking from the eyes of the drone, and you are getting that data directly over here, and the robot is giving you some commands, some information, and the robot, the drone has landed. So this is an integrated platform, as I stated, and you can simulate mobile robots, you can simulate air vehicles, like drones or UAVs and others, and these are all possible in that sense. What I would like to show also, you can make use of also some visualizations. For example, let me open this project. You can. There is a visualization section on riders on the ride editor, so that you can get some data over the platform. So while this is opening, let me continue with the presentation. So one of the best opportunities of Riders is providing is the competitions, and we have held until now many different competitions, and these were very successful. There were over 100 registrations and contestants, and there were more than 20 hours of coding per user in those competitions. So for example, this was a drone competition. This was a Maker Faire drone race, and you are seeing how you are coding, either coding or using some keyboard functionality, but you can code also your keyboard, your own keyboard as well. So this is also one of the nice features of the Riders platform. And with that competition, there were over 80 participants in that competition, and 20 hours of coding, basically. And there were also a line follower competition, which is similar to what I show right now in the Maker Faire. And there is right now a competition going on with the same concept. So there is a drone race. There's a drone race right now, and there is a line follower race. So if you can invite your students to those competitions, that will be great. Maybe they can compete between each other. So what I would like to also add is there are some upcoming features right now, which might be very interesting. One of them is the development tools, and where you can easily embed a robot or environment. As a second, we are not going to stay only in the simulation. What you can do, what you will be able to do is you will be able to deploy the code on the riders directly on a robot, which is running on a ROS based, and we are providing you an image for a Raspberry Pi, for example, so that you can code over cloud directly a Raspberry Pi in seconds, and you can basically code and manage a fleet of Raspberry Pis even directly over a Riders platform and robots. And what we are going to provide also the scalability of the simulation. So right now it is almost impossible, or it requires a lot of investments for universities if you want to do a large scale simulation. But in this case, in this scalable simulations, what we are going to provide you is you can configure the CPU, the number of CPUs, the RAM of the machine, the GPUs, and everything, so that you can build your cloud system, configure your cloud system, and run the simulation on top of that. And another important feature that we are going to provide is reuse others' development. For example, if you have developed something like an algorithm which is doing a mapping over a LiDAR, this will be available for others to use in their projects, because we are providing a community system, as I explained in workgroup modes and etc., and public and private project system. This will be also possible. And finally, if you would like to work on your local machine, and you, for example, if you don't have any internet access at that point, we are going to provide you an executable as well, so that you can open up your projects from your executable on your local drive and local system. Right now, 9 high schools in most of the part in United States and Turkey are using Riders platform via available curriculums. And 7 universities, including Bilkent, Middle East Technical University, these are one of the best universities of Turkey, are using Riders platform for their courses, especially on ROS, based on ROS. and also for some projects which are where the research lab is collaboratively working on. So I can say that Riders platform is something very interesting for the students, because they can try, it is a virtual lab actually in terms of robotics, and you can have a lot of possibilities in terms of machine learning, control, image processing, and others. Would like to show you one thing so that you can see what I mean. So what I'm opening is as like a very simple case, right? So this is a square of walls, and there's this robot. There's this robot with a distance sensor on it, this white one, as you're seeing, and it is moving all around. But what you can simply do is you just click to the visualize sensors, and it is opening up. And once it is opened, I'm going to take it to the left so that we can have a look together. So what I'm going to do is I'm going to select TF here, the point cloud. Exactly. We would like to show one more thing here. As the robot is moving, it is mapping the environment all around on a 3D environment. So you have the flexibility of visualizing the sensor data on 3D space, and you can also plot that data, or you can also understand the environment. So as you're seeing, you are seeing the robot and the sensor frame, and it is measuring the sensor data in world coordinates, and it is placing in the 3D world, and it's creating the map. So these functionalities are available here, and what you can also do is 3D mapping of systems as well. So as I stated, this is an experimentation platform for the students to learn coding, to learn the aspects of robotics in an advanced level, and to apply machine learning and artificial intelligence algorithms on the fly without installing anything and without any hassle. So, and they can share their work with their friends, with their community. Riders enables them to engage with the community by competitions as well, by improving themselves over courses. And so that our aim is trying to be the home of robot developers. This is our vision and mission in that sense. So that's why actually we need your help. We are trying to create an ambassador program where if we can work together, we can provide you a special discounts for your university or for your school. Or if you can do an affiliation and refer us to a school, we can create a revenue sharing model with you. We can work basically together on this. So if you are interested to be an ambassador of Riders, we are going to give you a free training as well. And if you can connect with us over an email and say, I'm interested, so that we can discuss about it further. So our next webinar dates will be on the 18th of February and 25th of February. If you want to listen, we are going to put in every webinar a different and a new functionality and a project maybe which can be very interesting. And if you would like to follow us, please subscribe to our social media channels and visit our website, and please also attend to our competitions. Thank you very much for listening. I hope it wasn't that boring in the first place. And if you have any questions, please ask me so that I can answer as good as possible.